it works on the principle of the Wheatstone network. Okay, these are like a keys. Yeah, it will be. When you remove this plug, here the gap. Here, you know, so there's a 1 ohm, 2 ohms, 2 ohm, 5 ohm, 10 ohm. If you remove here plug, if you remove this one, no, then that 1 ohm will get added up. When it is placed, there won't be resistance. So now no resistance between P and Q. Between, say, like, we'll write some name. No symbols. AB. I'll write it. There won't be any resistance between points A and B. Same thing when you remove that plug. When you remove that plug, there'll be resistance will come. I'll write it nearby 2 ohm. The 2 ohm will get added up. Okay, got the idea now? So when that plug is inserted tightly, no resistance. When the plug is removed, then we'll get a resistance. Okay, idea? This one? So these are based on Wheatstone network. So these are unknown resistance. These are the, so like a resistance arms. There's a resistance box. The resistance box is everything, this one. Huh? So from here, there's a value of R. Some other color. Everything will be the, and this point will be infinity. Open circuit. We can make that open circuit also. And the unknown resistance is this one. Okay, the ratio arms, what you can see here, there's a Q, there's a P. It's very easier. You need not to bother much. You just understand the methodology involved. Already we discussed. So now the whole setup will be available as a like a Wheatstone network. Now, why it is called as specifically the post office box? So this will be really troublesome. If you look at the Telegram, earlier we would add like how we have SMS, no, the Telegram. So I want to send a message that to some emergency. So I'll go for post office box. Then I'll go to write the message. So for each and every word, 10 rupees. One alphabet. One alphabet, 10 rupees. So like some, please come, please start your journey immediately to Hyderabad. Okay, then for every word, one alphabet, 10 rupees. Okay, they have to send. How do they? In the Telegram machine open, they used to use this equipment. That's why it was very popularly used. So therefore, they started calling it as post office box. Okay, got the idea now? This one, the basic purpose of Wheatstone is to measure the quality of sand. That purpose, it was introduced by one botanist. No engineer, nothing, nobody has come into picture. To measure the sand quality, the fertility of soil, everything, so we use this one because the particular land where the sand is available, where I'm going to go for the I want to do agriculture. I want to check the quality of sand. So the fertility depends upon its resistivity. Because why the resistivity is needed? Because that particular sand has to absorb the nutrition from the earth. And what we have nutrition is like all the elements, ions, So if it's having certain conductivity, it's good, no, it can absorb. So therefore, the resistivity of the soil matters a lot. So to measure this resistivity, this Wheatstone network is introduced. That is the main purpose. So can be asked in mains, if not in advance. The sand, like a fertility is directly proportional to, or in passages, they may introduce this idea. The fertility of sand depends upon the resistivity of the sand. The resistivity is what we can determine here. No? Okay, the ratio arms. So what is a why not Wheatstone network? Why we are using this post office box? Why we are coming for Wheatstone network? The Wheatstone network open here, there, the accuracy we cannot, the precision not possible. Means 10 ohm. Okay, 10 ohm, that one 10 point, like a the second decimal place, third decimal place cannot be predicted. Suppose if we have 7 point. In Wheatstone network, the second, third decimal places, or even the first decimal places, predicting exactly not possible. In post office box, even the third decimal place we can predict exactly. That's why compared to Wheatstone network, this is widely preferred. By adjusting the ratio arms, I can choose the decimal place. So first, usually the ratio, it will be made 1:1. So here I'll plug 10 ohm, 10 ohm. Then according to this, x equal to q by pr. So q by p is 10 and 10. Then in the beginning, first experiment, first data is what a very troublesome. Once you get the first data, the other things you can manage. Other things you can manage here. So what actually happens is like the first data, p by q. So first 10 ohm, 10 ohm, I removed it. Then first, which key should be pressed here? The galvanometer key or the battery key? I think long back we have discussed. So here is telling that information. Check the deflection by in the galvanometer by pressing the key K1, then galvanometer key K2. Any reason? First, I should press the key K1. Where is the key K1? It's one. It is connected to cell, no? And key K2 is connected to galvanometer. So that K1, K2, let me indicate here. First, why? First, which key? The K1 key should be pressed first, then K2. Any reason for that? So once I press K1, so immediately what type of currents will flow? Transient currents, RLRC circuit, RLC circuit. Well, sir, where is the capacitor? Capacitor doesn't mean that there should be capacitor. No, this wire also will have a capacitance. But where is the inductor? This wire will also have inductance. This is not inductor. Huh? These two wires will have inductance, mutual inductance. So many parameters. These two will have capacitance. So like that, any electrical electronic circuit, they will have a parasitic resistance, capacitance, and inductance. When you press first the battery key K1, the circuit will be like a RLC circuit. And we know what is the current, a varying current. A transient current will flow. And how long it will flow? For a short duration of time. Or how long this current will flow? For short duration of time. Okay, guys, for short duration of time, this current will flow. What is this time? 5 lambda, 30 microsecond or 40 microsecond. So initially there's a transient current. Afterwards, steady state current. Now, if a transient current flows, so suppose you press K1, K2 both simultaneously. So here a transient current will flow. It may, the galvanometer may receive inductive kick, in the sense a sudden deflection it will show, and it may damage the galvanometer. So to avoid that inductive kick or to avoid the transient current flowing through the galvanometer, First K1 I should press. Once K1 is pressed, what is the problem? What are the transient current, they'll settle and a steady state current will flow. Then when I press the K2, no, then what all current will be flowing is the steady state current. So that will not give any inductive kick to the galvanometer. Oh, sir, what will happen? Inductive kick. The pointer should not deflect suddenly. And with that, what will happen? The elastic string which will be there, no, in the galvanometer, this will have torsional constant. And if I suddenly get twisted, no, after elastic effects will come into picture. It may lose its elasticity. For that purpose, what will happen? And this is very important. Once it loses elasticity, you have to put this galvanometer in dustbin. So for that purpose, to avoid inductive kick in the galvanometer, first the battery key K1, then K2 should be closed. Or in the sense, the transients will be eliminated. First, if you press K1 with K2 open, then what will happen? A transient current which is flowing will get nullified and only steady state can flow. Then you press K2. This is the main key, a very important part. No, sir, I will press first. I'll press K2, then K1. If you press K2 and K1, definitely there's a possibility of galvanometer may get damaged. That's the reason. Got the idea how to take the reading? Then what you should do? You should make a guess of the value of R and how the what type of galvanometer I'll be picking up. I'll be picking up galvanometer where the pointer should be in the middle. This is scale. Okay, the pointer should be what happened at the zero, that one. Getting the idea now? This will be why it should be this one. So when the R is something 4 or 5, no? If you make 3 ohm, the pointer will be on one side. If you make some 8 ohm, the pointer will be somewhere here. So how do you come to know it's a 4 or 5? The first reading is a very difficult one. If you can get the first reading, then it's okay. So while I'll do one thing, I'll start with some lower value, 2 ohm, 3 ohm, that one. So as the reading approaches between 4.5 or something, no, the pointer will be here. Also like a 4 ohm, 4 to 5, this one. If it's a 8 ohm, the pointer will be here. If it's a 1 or 2 ohm, it will be here. The value of R. So after this, the value is between 4 and 5. Next, I will increase the ratio arm. Q by P, I'll make it 1 by 10. Then R what I'll start directly from 40. 40, or select this is some 100, you take it. Deflections, huh? This will be much easier. 10 only, 10 only. I don't know why I'm changing. No. Come for this. So no, this will be 40, no. So for 35 ohm, the deflection will be here. 35, 36, 38, 40, somewhere 42 will be here. Next, what we get is here like, so if I increase further, 43, 44, 45, 50 will be here. So first I'll take 40, the pointer is here. If I make 50, the pointer is here. Then they show that the answer is between 30 and 50, 40 and 50. Then I'll start adjusting it. 35 and say 50. Then what does it mean? Somewhere between 35, 50, the pointer will be at 0. So I'll slowly vary the values. Where the pointer becomes 0, I'll note down the value. So it will be 42. So like that. Next, again, what happen? I'll make the ratio of arms 1 by 100. Then I'll start with 400. Then from 400 to 450, I'll check it. The pointer, if it 400 here, 450 here, so the way the answer lies, the zero deflection may come between 400 and 450. Then I'll adjust the value. I'll calculate the value of R. I'll note down the value of X. Then I'll take the mean of that. We'll get the required answer. Okay, there's a very popular This one. So actually, we don't do in lab also. I think you check meter bridge. Okay, experiment is there, but in this also not there. But in exam, they do ask three times in advance and two times in mains. Theoretical ideas: the galvanometer, the scale should be zero between the zero should be the midpoint of the scale. And next again, what we needed again, the first the battery key, then galvanometer key should be pressed here, and these are called like a ratio arms. From with this weapon, you can control the accuracy, or say better say precision. Sorry. Any doubt? This will be very difficult experiment for students to really understand. I'll just give the set of diagrams so that you'll understand. 35 to 50 will be like this. This is second diagram. The point this is for 2 ohm, 8 ohm. Next again, this will be say some 35 pointer will be here. They may trouble you with data like this also. Please, that's why I'm just giving some information. This should be 35. Next, you'll see this. Minus 10 and plus 10 are the deflections. They are the scale of galvanometer. What are 2 ohm and 8 ohm? Somebody is asking, sir, what is this 35? Okay, no, at least. This will be okay. Agree this this one. Any doubts in post office box? You can clarify. Completed, no problem. 13 135. Okay, I'll continue from tomorrow. Tomorrow I can take class. Better we'll have tomorrow class. No, again why to.